Yeah, good afternoon, everyone. Thanks for being patient in the very long journey today. This is Youngsoo. I'm taking the head of Standardization Korea of Nokia. Also, I'm actively attending the 3PP meeting for the 5G standardization. So it's my pleasure to be a part of this presenter. So hope my talk will be very impressive or useful to you. I will talk about some technologies to shape 6G, and especially I will focus on some the day one topic. So in the morning session, my colleagues already emphasized on the reality of 6G. So even we need some more innovative technologies, but to make a success for the 6G, I think the reality is also quite important. So this slide is kind of showing some overall principle of 6G. So as many already mentioned, that we are facing the different trends and the challenges like higher demand for the performance. Also, we are observing the many different types of devices coming. Also, maybe there is very AI is one of key. Also, we are getting more and more interest on the AI API economy. So with this trend and challenge, so how 6G will address these challenges? Regarding to the design principle, we think at least the 6G should should be designed based on some value-centric approach. Even though we are also emphasizing on the AI-driven, but not only for AI-driven. Anyway, that in order to be very productive and meaningful success in the 6G, the 6G should ensure that this provides the real the value to the operators and the users, something like that. So as a top line, we think at least for the business perspective, the revenue and the business growth should be guaranteed. Also at the bottom line, we need some lifts in performance. Also, some cost-efficient way should be supported. In addition to the legacy, traditional the capability of the throughput or the latency, reliability, etc. So we also need to consider another aspect, right? Currently, the world is collaborating to be more safe world and then sustainable world. So the sustainability or the trustworthiness or even the digital inclusion should be also kind of some very important design principle for the 6G. Yeah, so I think the 6G, when we record the 5G, start the beginning of the 5G, yeah, even we started with the very innovative technologies, but the reality of the beginning of 5G was we started with some the technologies support already introduced for the end of 4G stage. So similarly, we are thinking that 5G or the 5G advanced should be a very foundation of the 6G baseline, and we will add additional some innovative technologies on top of this one. In that sense, we can consider two different phases. One is the 6G day one focus and some beyond. Especially regarding to the day one focus, I think this is quite important because to make sure the success of the 6G, also some flexible and very extensible 6G design in the day one should be a very key of the 6G success. So in that sense, the Nokia has identified the 6 representing technologies for 6G day one focus. Of course, we will further consider some beyond technology, but at this time, I will more focus on the day one focus technologies. Okay, first, currently, also I'm very deeply involved to the MIMO technology because also I'm delegate for the MIMO technology in the 3PP, and also I realized that in the success of a 5G, the MIMO, massive MIMO should take a very big role. So similarly, I think in order to get more innovative performance improvement, then the extreme MIMO should be one of the key technologies. Also, connecting to the WIC 23 decision, so the new band is also quite important. You know, why the new band is important? To my understanding, having more antenna elements and having more layers, having more the beam gain are quite important part to improve the performance. And same thing can be happening in the 6G. So if we go to the upper spectrum, like 6.4 to 4.8, then we can assume the larger bandwidth will be available. Also, the antenna can be smaller. Then within the same antenna size, we can equip more and more antennas. If we assume, for example, if we compare the 3.5 gigahertz and then the 7 gigahertz, then simply we can assume the 4 times more antenna element can be equipped. Then if we are recently the 64 TRX with around 200 antenna elements are quite common, and now we can assume the more than up to 1,000 the antenna element can be equipped within the same size. This may provide a better gain, also better layers, the special multiplexing, something like that. So I think that this extreme MIMO should be the very key. We evaluated massive MIMO, extreme MIMO, with the comparison study between 3.5 gigahertz and 7 gigahertz. Also, we included some results regarding to 13 gigahertz. But if we just focus on the 3.5 and the 7 gigahertz, then by accepting some number of antennas, more and more antennas, we can achieve up to three times more the cell capacity, UE capacity. This is just UE capacity. If we assume the number of more antennas in the UERX, also larger bandwidth, then we can simply increase the peak throughput or mean throughput by three times more. Also, actually, this time regarding not only for the higher frequency, but even for the low frequency, we can also consider discrete MIMO as some innovative the evolution technology for the 6G. Okay, so we also evaluated this MIMO performance with some field trial. So this has been released in the recent ECC PT1 meeting. We contributed with some results. I think you can easily access this result. We used two radio in the same location. As you see here, there is 3.5 gigahertz and 7 gigahertz radio with almost the same size. This radio is somewhat commercial ready product, so we started from the 128 TRX for the 7 gigahertz. And based on our measurement test, we observed that at least with the LOS condition, up to 600 meters, the almost comparable RSS-RP measurement result can be achieved. So for information, we only get some limited license for the transmission power for this the 7 gigahertz. So the number in the table, bottom table low is some normalized RSIP value because the transmission power is 23 dBm lower than the commercial product. So if we change it, normalize it, normalize it, then you can find that the difference, RSIP difference is not quite big, right? So in addition, also we evaluated the omnic performance as well. So at 250 meter distance with a 60 megahertz bandwidth, we observed that the omnic throughput is quite similar, and around almost 90% of omnic performance can be achieved from the 7 gigahertz radio over 3.5 gigahertz radio. So in that sense, we would like to make sure that the new radio will be supported with the same the site grid with existing 3.5 gigahertz radio. So I think we will continue to evaluate the performance, including the line of sight cases, also some with the commercial ready UE device. Next technology is single architecture for simple evolution. So thanks Ericsson that already provided some background. So as you remember, when we recorded in the beginning of 5G, we had very different types of architectures. Architecture option 1 to 7, right? Yeah, even we didn't consider to deploy everything, but this the fragmentation makes the delay in the migration to the standalone. So in 6G, we really want to keep this network architecture as a simple. So we strongly propose to go with standalone architecture only. So in UE perspective, if when we compare the standalone and non-standalone, in the UE perspective, UE should connect it to the both 4G and 5G. And then, for example, omnic transition antennas are separated. Then the two TX antenna, omnic MIMO, is not hardly implemented. Also, the power consumption is quite high. So the NSA could be good enough, but in some sense, it increased the complexity and some performance degradation in some sense. So in that sense, going with a single standalone architecture is quite important. But as Ericsson already mentioned, that the hurdle for this simple migration is the legacy users and legacy system. So we cannot swap every 5G or 4G spectrum to 6G at one time, and then also we cannot swap change every UEs to support the 6G at the same time. So as a solution in 5G, we consider the DSS, dynamic spectrum sharing, for between 4G and 5G, which means that one spectrum can be shared by the 5G and 4G dynamically within the multi-lat radio. But there was some issue because due to the CLS and the very constant overhead of 4G, the total overhead was quite high when supporting the DSS. So it was not very attractive. But thanks to the lean design of 5G, we removed the CLS, we removed the many periodic signals in 5G, and we can easily support dynamic sharing of spectrum between 5G and 6G. So this is quite a good background. So if we consider the single LAT, so I think that the MRSS is one of a very important technology to us. The MRSS is the technology to share the spectrum by multi-lat device, GNOB, and the UE only connected to a single network only. This is UE transparent way. And then GNOB can dynamically change its resource to here at the 5G and 6G in time domain or the frequency domain or even the spatial domain. Spatial domain, I think that we need more study or the feasibility of that. But at least for the time domain or the frequency domain, the spectrum sharing, dynamic spectrum sharing is feasible. We performed some evaluation in the cell level perspective. If we compare the overhead and the throughput, then compared to the 5G only or the static cases, with or without joint scheduling or not. Okay, so we evaluated the cell throughput with the assumption of single the minimum control overhead and the double control overhead. And in case of a minimum control overhead, almost the same performance as NR only is achieved, or with some double overhead, we can achieve up to 90% of cell level efficiency. Also, we evaluated some simulation, evaluated the MRSS performance in the DL performance as a function of UE throughput versus cell throughput. If in case of the static cases, then the overhead is limiting factor to increase the cell throughput according to when the number of UE increase. So, but if we consider some MRSS with joint or the distributed scheduler, then the performance gap between MRSS and NR only are quite small. So we assume that that in these cases the joint scheduler with the dynamic joint scheduler is almost the same performance as the NR only. And then if you see the dashed line, that's representing the result of a dual scheduler, which is separate scheduler, but very regular. Periodically, the information is exchanged between 5G and 6G G-Node B, but still it's manageable, right? So I think the MRSS is very much useful to support smooth and easy migration from the 5G spectrum to the 6G. So that should be very key for success of 6G. Okay, so I think that those two are kind of a very important aspect for the reality. And then now, the other part is very similar as the others already mentioned. I'm not very expert on the API or the program network, but I was in some IT company, and then Open API and Cloud Native and programmable networks SDN were very much basic assumption in the IT domain. And also now the communication systems are also being integrated with the IT computing system. So then having the programmable network for the customized service, also exposure API for monetization, additional monetization for the service is quite impressive, important, and very basic for that. So the 6G should be evolved to support this kind of the flexible network evolution. Also, everybody says about the AI. So yeah, I'm not expert on that, the other the presenter. But what we are talking about is that AI should not be a very local optimization. So it should cover the end-to-end optimization, and every the network component will equip its own the native AI, and then all this AI end-to-end system AI and native AI should incorporate it with some better end-to-end UE the experience. Also, in order to support this one, what is important is we think that unified and uniform the exposure of AI API is quite important. Otherwise, then it's not easy to mix them up in the combining those several different AI functionalities in one single system. So these two parts should be the baseline for the AI. Okay, the green for 6G is always one must-have for the 6G. Yeah, sometimes I heard that rather than to peak throughput, the operators are more interested in the this power consumption. So there are several different aspects of you can see in the left side, and there are several aspects regarding to implementation. So we need more energy efficient devices, RF hardware, and power, and also we need some network optimization. Yeah, we already provided such solutions in the 5G system, but 6G should be more innovative and more efficient than the 5G. Also, in specification perspective, we need the software or the standard should support more innovative energy saving function. We started network energy saving 3GPP, and that should be the baseline of 6G as well. Also, the AI-based energy saving is one of the key item. So some says that the AI usually consume larger power. Then how we can compensate this the large power consumption with respect to the 6G energy saving? But I think this optimization may not happen every time. So then we can find some middle ground of supporting both AI ML can support the enough level of power saving without consuming larger number of computation power. So one of the key 6G design principle was digital inclusion. Also, the ubiquitous 6G service is quite an important requirement from the ITR requirement. So I think we think that NTN is one of the key technology to support this one. And then to support such a ubiquitous coverage, we believe that those features should be supported. First one is that end-to-end should not be only for the smartphone or only limited device. You know, in 3GPP also we have a simulation. We have the standard for IoT NTN. IoT is also quite important to provide some, environmental sensing or something like that. Also, there should be very different types of device will be there. So the NR should support all this kind of device through both TN and NTN with the same common design. Also, the GNSS requirement is somewhat problematic. In 3GPP, currently we assume that the NTN device need to be synchronized with the GNSS, but this is somewhat very big restriction. So we should strive to remove this restriction to support a larger variety of the device types. And also, TN and NTN interlocking is quite important. So, yeah, anyway, the NTN, we don't know how strongly NTN take a role in the 6G. Even, especially for the Korea, we are already saying that where the use case is. But based on this kind of discussion, we can reach to some solution for the NTN's role. In addition to the day-on focus, so we also consider some beyond for the day-on focus. Network as a sensor is one of the key enablers for monetization based on the existing network infrastructure. The drone monitoring or the environmental sensing, weather sensing or the healthcare, autonomous driving, something like that, or robotics are quite, there are many different use cases already supported. So by applying the additional RX node or the additional implementation, RX receiver implementation, the network easily can support the network sensing with or without standard support. This shows our the POC equipped in the Arena 2036 in Frankfurt in Germany. So we have successfully tested the robot tracing based on the network as a sensing. Also, Nokia Bell invented Unix in 1970s, and this was one of the innovation for the computing. Now we are talking about combining of sensing, computing and communication. So we are considered that the Unix can be one of a big game changer for programmable network. And then I don't know in detail, but maybe if based on this integration of computing and communication, such a unified operating system or programmable network management should be quite important thing. Also, energy efficient ASIC development is quite important. Also, we are very much we strive to develop some good ASIC for the extreme MIMO support, because extreme MIMO requires high complexity for the computation, and also the energy consumption should be very low. So the ASIC technology is quite key for our the 6G success. with this background, we are actively collaborating with several industry partners. We provided some AI native air interface POC with collaboration with the SK Telecom, NTT Docomo, and NTT. And also, we tested with how to support the wireless AI interoperability with the Qualcomm. And also, as mentioned already, for the integrated sensing, so we collaborated with the Bosch and the other parts. So hopefully, this kind of collaboration will fasten the 6G success. Yeah, we are also collaborating with the academias, forums. Sorry, I skipped this one. We are the member of the 6G forum, and we are also leading the HexaX2 or the 6G ANA or something like that. So we, as a global the partners, we strive to be a very good supporter for the EC group. So we believe the power of N, and we also believe the beyond the power of N. Thank you.
Thank you very much.